Talk about note card 46, finding inverses algebraically. We have pretty much a few simple steps here. Kellick, turn around, you're freaking me out right now. Change f of x to y in the equation. The second thing, we're going to interchange x and y or make them trade places. And 3, solve for y where it exists now, and the new equation is my inverse. Let's look at example 1. First thing we want to do is we want to change f of x to y. So I have y equals 3x plus 2. Then I want to interchange x and y. So I have x equals 3y plus 2. And now I want to solve for y. So I'm going to subtract 2 from each side. That cancels. I have x minus 2 is equal to 3y divided by 3. And I get that y is equal to x minus 2 divided by 3. And this is your answer. That's your inverse. However, if you have to graph this, you might want to make sure that you can look at the form that's a little more friendly with graphing. Y equals mx plus b. And that looks like this. This is the same thing as x thirds minus 2 thirds, which is the same thing as 1/3 x minus 2 thirds. And the reason you want to be able to look at this version is because you can easily see your slope and your y-intercept, which makes it easy for graphing. So you need to be able to equate this version with this version. Moving on. Example 2. Just going to go through the same steps. Change f of x to y. So I have y equals square root 4x minus 1. Interchange x and y. So I have x equals square root of 4y minus 1. Now I want to solve for y. It's a little different looking. You may be a little confused on how to solve for y in this case. What you already have probably recognized is that the y is inside this expression that's inside this radical. So hopefully you can see that we need to eliminate the radical, and we're going to do that by multiplying both sides by the inverse of this radical or the square root. And hopefully that you know the inverse of a square root is a square. So we want to square both sides. By doing that, I get x squared is equal to 4y minus 1. Don't make it any harder than it has to be. If I square this entire right side, the only thing that happens is the square makes the radical go away, and I'm just left with what's underneath there. Okay, still solving for y, so I want to add 1 to each side. And I get x squared plus 1 equals 4y divided by 4. And I get that y is equal to x squared plus 1 over 4. And because it's a quadratic, no need to put it in y equals mx plus b format. Those are only for linear functions. This is your answer. This is your inverse. Done there. Okay, now I think that those two examples were a little bit easy. I hope they were anyway. So I'm going to look at a couple problems from the homework. One of your 3 homework assignments. This is going to be 4C, which is on the back of the inverses homework assignment when you were graphing, looking at inverses graphically. So for C, we have f of x is equal to 1 over x. So I'm going to go through my steps, change f of x to y. So I have y is equal to 1 over x. Next step is to interchange x and y. So I have x is equal to 1 over y. And now I want to solve for y. So there's a few different ways we can solve for y here. What we're doing in this fraction, the variable that I'm looking for, that I want to solve for, is on bottom. So there's a couple of steps you have to take here to do this. Probably the easiest way to solve for y here, what most of you will feel comfortable with doing, is you have a fraction on the right hand side, but you don't have a fraction on the left. But you can make the left hand side a fraction by putting it over 1. Now that you do that, you can cross multiply and divide. So x times y is xy, and 1 times 1 is 1. We're solving for y. X and y are being multiplied, so we divide by x on each side, and we get that y is equal to 1 over x. That's probably going to be the way that most of you will like to do. It's probably the least confusing. But for fun, let me show you a couple things. If you have x is equal to 1 over y, one way of solving for y would be 1 is being divided by y, and we can eliminate this fraction by multiplying both sides by y. This cancels, and I get 1 is equal to xy, which is basically what I had over here when I divide by x, and I get that y is equal to 1 over x. This is probably going to be your least favorite way to do it. However, it is a way. Now, something that you may have never seen before, I want to show you. It's very simple. Some of you will thank me for this, and some of you won't want to look at it just because you don't like new things. You like going with what works and sticking with it, and that's fine too. Watch how easy this is once I get the problem written down correctly. Alright, so I have x is equal to 1 over y, and I'm solving for y. I have 1 over y here, and I can take the reciprocal of this. 1 over y is y over 1, which is just y. And what you do to one side of the equation, you must do to the other. That's what the golden rule of algebra says. So if I take the reciprocal of the right side, I must take the reciprocal of the left side, and I'm done right there. Just a little bit of taking reciprocals. And I'll do one more. Before I go on to the next example, let me point out, you probably already noticed that in that specific example, we had f of x is equal to 1 over x, and when we found the inverse, we found y is equal to 1 over x, which is the same thing. The reason why it's the same thing, you can encounter these types of problems. You're going to have a couple on your homework. Here's what happens. If the graph of this regular function, if it already has symmetry in the line y equals x, then it's going to be its own inverse. Because remember that when we're looking at symmetry graphically, when we're looking at inverses graphically, inverses have symmetry within the line y equals x, or the reflections of each other in the line y equals x. So if your graph by nature already has that symmetry in the line, if we look at this graph, you should recall this graph, if we're looking at our xy plane, looks kind of like this. And so without a doubt, even looking at this graph, you should already know, now that I've told you, that since these are basically a reflection in the line y equals x, this one graph is, then it's going to be its own inverse, because it already has that symmetry or that reflection in the line y equals x. Okay, and I'm going to do one more example, and this is also from your homework assignment. This is going to be 4D. F of x is equal to 1 over x plus 2. So, change f of x to y. Y equals 1 over x plus 2. Interchange x and y. X equals 1 over y plus 2. Solve for y. The easiest way to do it, if I take the reciprocal of the right side, I have y plus 2 equals, the reciprocal of the left is 1 over x. Subtract 2 from each side, and I get that y is equal to 1 over x minus 2, and I'm done. For those of you that are not comfortable with that method, starting over, if I have x equals 1 over y plus 2, the easiest way to that some of you probably see it a little bit easier, or maybe you're just more comfortable with it, make this side a fraction, cross multiply. 1 times 1 is 1, equals x times y plus 2. Since I'm solving for y, there's no need to distribute this x inside the parentheses there. That's going to create a little extra work. Since x is being multiplied by this sum, y plus 2, go ahead and divide by x to get rid of it, to make it go to the other side. So I have y plus 2 is equal to 1 over x. Subtract 2 from each side. And again, I get that y is equal to 1 over x minus 2. Either way, pick or choose. There's typically a few different ways to solve each equation. Work with what you feel most comfortable with.